Hi students. So today I'm discussing application number 6 based on the work done. Once I see the application, work a uniform chain of mass is given here, capital M is given, and that uniform chain length is given capital F. This uniform chain is suspended vertically. So the lower end of the chain is lifted up to point of suspension. According to this application, now I'm going to draw the diagram once we can see here. Now I'm taking one rigid support. This is the rigid support I consider. For this rigid support, I will take a uniform chain and this is suspended vertically downward in this case. We can observe very clearly this is the chain here, uniform chain. Right. This is the uniform chain. Right. Fine. So this is the uniform chain means the total mass in this case. I am taking mass of chain is capital M. Length of chain is capital L is given. So this is the uniform chain means I am taking this is the center of gravity, nothing but the total mass of this chain is located at this point. So that is I'm taking in this case G1. G1 is the center of gravity is the G1. Can you please see if second point the lower end of the chain is lifted up till point of the suspension. Means here the point of suspension here, this is the point of suspension. Now I'm holding this lower part, I'm lifting to vertically upward. Once if I lift this chain to vertically upward in this case, it is forming like this. You please observe in this case. This is the part. Again it will go. Please observe the diagram very clearly. Now it is become like this. So this is the G1. So only when I lifted this one, this is the length is here L by 2 and the upper part from the G1 we called as length is L by 2. So I'm lifting, when I lifted this chain from the second end to the top, again the image diagram is happening like this. From this part length is L by 2. Total height, how much of height this lifted in this case, the chain is lifted means L by 2. So now I'm taking the one part of the, I'm taking here, this is also center of the gravity in this case, half chain if I'm considering. This is I'm considering in this case G2, center of the gravity 2 when I lifted to vertically upward in this case. So I'm considering only this part of the chain. Total mass is a capital M, and the lower part I'm considering mass in this case m divided by 2. M divided by 2. And when I'm applying this for I mean nothing lifted to upside, the height is upward in this case, and the mass is acting weight is acting vertically downward. So actually what is the formula in this case? The formula is W is equal to force into displacement into cos theta. Here theta is the angle between force and displacement. Here force is nothing but we are finding work done by the gravitational force is the Wg, nothing but Fg also. So Fg is nothing but in this case mass into gravity. So I will take mass in this case m divided by 2. Why I'm taking mass is m by 2 means in this case I'm the lower end of the chain is lifted means in this case only half mass is in this case lifting in this case. Okay, then m by 2, and s is equal to displacement nothing but height. How much of height I lifted in this case means L by 2 into sorry, g is the acceleration, this is the weight formula m into g, but mass is equal to m by 2. And in this case the displacement is nothing but here um s, no, this is L by 2 in this case, that is a L by 2. So now we can see in this case theta value how much in this case. Theta is the angle between Fg, nothing but gravitational for gravitational potential, and L by 2 is the distance. It is going, the distance is the upward in this case, height, that is nothing but L by 2. And again the gravitational force is acting downward. Fg is equal to m by 2 into in this case g. Both are in opposite direction, so angle is 180 degrees. So cos 180 value is in this case minus 1. So finally work done by the gravity on this chain, we are lifting this lower end of the chain up to the point of suspension. Wg is equal to minus mg L divided by 2 into 2 is equal to 4. Okay, so this is the work done. We lifted the chain to up to the point of suspension. Okay, thank you so much.